We received your email, sir, on the syllabus.
Okay, very good.
For sharing.
Okay. Yeah, let me share this one. PPT. Are you able to see the PPT now?
Yes, sir. It is coming, sir.
Okay. So yesterday we talked about this digital SLR camera.
Yes, sir. Sir. This is your talk.
Yeah, we talked about this.
And next page also we talked.
So
and this page.
Yeah, basically we thank you. What we are going to see, these are examples for mechatronics. As I told you that there are 3 motors. I say M1, there's a M2, M3. These motors are driven by 3 motor drivers, which are controlled by a system controller, which is going to control this motor so that as I told you, this lens will be moved from plus or minus some distance. Lens barrel. This barrel will be, the lens end will be moved by a motor. That motor is this M1 motor. M1 motor will be moved so that the image, but if there's an image in front of the camera, that will be focused. Light coming emitted by this will be focused on it, on this sensor as an inverted image, right? So that will be captured by the sensor. So now how this is automatic camera. Manual camera means what you will do, you will see through your eyes and you will adjust this. Manually you will adjust this barrel using your fingers. So the lens goes front and back. So the sharp image comes on this and you can see it here. Then you do. It is a manual camera. Digital camera has the control of the digital image sensor. How it knows? As I told you, now if you think that this is the current location X0, this will be moved plus or minus, say for example 10 mm distance or 20 mm distance, both sides. Okay, plus or minus 20 mm will be moved from the current location by this motor, M1 motor. When it moves, what will happen is, as it moves, if the image is out of focus, the signal received by signals will be weak. Correct? This is the amplitude of the signal. This is the position. Correct? So when it is in current position, if it moves on particular position, you will get a maximum signal, peak signal for when it moves. Immediately the knows that object it at best to a position. Similarly, the second mode will be controlled, so the light will be adjusted. That also going to have an effect on the picture received on the sensor. Then finally, when both is first focus, the light amount or first light aperture, correct? This is called iris or aperture. Aperture is controlled by a motor, second motor. That what will is aperture will be it is called a diaphragm. If you see in the camera, it will be they call it a diaphragm. It can open the size bigger and smaller. Correct? So when too much light is there, the aperture will open very small. That is sufficient to take a good picture. If night time is, the aperture will open maximum. So that is the second one. This is aperture iris control. That will be adjusted by the everything done by this camera control digital signal processor. And then after that, shutter will be opened, picture will be recorded. So that's how the automatic camera works. Correct? The procedure is first adjust the lens position from the current position by activating this motor. Once a sharp picture is come, then the aperture will be controlled. Correct? So aperture control amount of light going. Many camera first you will do aperture control. Correct? Aperture will be adjusted based on light intensity. How that means light intensity means there will be a light sensor. There will be a light sensor in the camera, top of the near the flash. You will see a light sensor. That sensor will be somewhere here in the front. Here you will have a light sensor, ambient light sensor they call it, or somewhere in the front. So based on light, the aperture will be opened or made a small opening, be medium size or bigger opening. It adjusts. Already the camera is programmed. Okay. After that, the the lens will be adjusted, sharp image comes. Finally, the shutter will be open. This is the shutter, right? This is called shutter. Shutter will open, so the image will focus on the will be recorded on the sensor. That will be stored in the memory through signal processing noise. This is the amplifier. Amplified signal will be converted to digital binary number by ADC. Then finally recorded in the memory. In the DSP, it has a memory also. That's what is mentioned here. Please see here. You have a memory where your pictures will be stored. This is the main controller or microcontroller DSP processor, which controls these motors and also taking picture and storing information done by this. So you have autofocus motor, shutter open motor, and then iris control motor. Okay. Then image will be stored. This is how it works. Okay. So this is an example for automatic camera. Another example can be hard disk also, because we can see many examples. One example is the computer hard disk. Computer hard disk also called as a mechatronic device. You can see that this, if you open your hard disk, the top cover, you will see the internal part. This is what inside this one. You can see that there is a shaft, central shaft. Okay, below that there is a motor. There's a motor. This motor is controlled by a controller. Inside this, there's a digital controller. Circuit is there, which is going to control the motor speed. And the shaft, you can see the discs are there, these discs. Correct? These are the discs. These discs, you can see that 1, 2, 3 discs are in this picture. You can see 3 discs. This is one, second one, third one. There are 3 discs. And this is top side. Similarly, there's a bottom side. This will be coated with magnetic material. The disc will be coated with magnetic material. Okay, and this is put on a common shaft. All 3 discs will be put on a common shaft. This is driven by a motor. When the motor rotates, all 3 discs will rotate. So the motor will be rotating generally something around 3000 RPM to 8000 RPM, even 10,000 RPM. But for a given hard disk, if you see that by a hard disk, if you see the specification, its speed will be specified. The motor will run at constant speed without varying, plus or minus maybe less than 1 RPM. Correct? As close as possible. Accuracy of the rotation is very important. That is controlled by a motor controller. This is a motor called a spindle motor. That means this is called spring on which the discs are attached. So the top and bottom side is coated with magnetic material. The disc is made of non-magnetic material. The disc is a stiff disc, correct? Maybe have 1 mm thick or 0.5 mm, which will be a non-magnetic material, which will be stiff. The stiff disc will be there, and which top and bottom there are 3, 4, 6 depending upon capacity. Then another thing, what is there? You can see this is called as read-write head. You see a cantilever. This is a cantilever, and this is attached to a stepper motor, SM. Okay, so in the tip there's a small magnetic coil. They're called read-write head. Please note that the read-write head will not touch the disc is rotating. The cantilever is just about it, few micrometer height, without touching. Now whenever I wanted to store some information on disk, the pulses will be sent like this. If I want to store information 0, you know that binary data in the computer data is stored as binary information, which is mentioned zeros and ones. Correct? This is, for example, this is 0, this is 1. 0 is represented 0 volts, 1 is represented 5 volts. So voltage of 0 volt, 5 volt will be sent to the read-write disk, read-write head. So whenever 5 volts comes, it will produce a magnetic correct? At the end, it will produce a magnet. Correct? Magnet will be that energy will be stored, so it will be magnetized. Where, as I told, whenever you have a data, for example, this with respect to time I am showing, this is 1, next is 0, next we say bit. This is bit 0, this is bit 1, this is bit 2. Like this it goes. The second bit is 0, third bit is 0. For example, fourth bit is 1. That is B3. Now, whenever it comes, it will be marked with some points. Right? Whenever you want to store 1, that spot alone will be magnetized by sending a voltage pulse here. This pulse will be sent to this one. Wherever it's not there, it will not be. So zeros I will represent green color. Correct? That means it is not magnetized. Here it is not magnetic. Here it is not magnetic. Here it is not magnetized. Okay. So now this is the data in your hard disk is stored. Correct? You send the zeros and one according to binary data. 0 means bit number, that means 0 volts. 1 means 5 volts. That will be create a magnetic field at read rate and tip. Since disk is rotating, a series of magnetic field, non-magnetic. Magnetic fields are represented by the maroon color. Wherever magnetic, this is ones, and this is 1. This is 1. And wherever 0 is, that marked as 0. Correct? Green color. So now this is by writing. This is called writing. When I want to write something, I magnetize this one head, so that particular equation will be a magnetic field. So that means you can see that the data is stored as a circular track. This is called as one track. Right? In this track, I can show zeros shown by magnetizing or not magnetizing that particular area. But the disk is rotating. Now, if it is over, that means if I fill all these points with some data, if I want to write more, what I will do is I activate my stepper motor. My stepper motor will move a little bit further. It will go to next this one. My read rate will be here. Now here I can write new data. Again, there's a circular because it is magnetically rotating. I can write my data. Wherever I want to 1, I magnetize. Wherever I want to write 0, no magnetizing. That part. So this is, I say this is track 1, this is track 2. Like that, I can create multi-track. In hard disk, if the generally the width of the track will be 1.5 feet something. In 1.5 feet, you may have 400 to even 800 tracks. Each track will be measuring width of the track will be micrometer. So that means more data can reserve. The hard disk data is stored. Okay. Now this is please note that the cantilever is a mechanical structure. The spindle is a mechanical. The whole thing is a mechanical structure. I want to control this motor speed very precisely. Spindle motor speed should be control very precisely. I have electronic control, and the stepper motor SM, and this is spindle motor SPM. I say both should be controlled. There's a embedded controller ECU. Correct? This is going to control this motor, and so the controlling the read rate head movement, I can make the read rate head to move, go to different tracks, so that I can store more data. This is how it works. This is another example of mechatronic system. Okay. Here, as I wanted to explain what it is, because if I want to improve the performance of the hard disk, I should store more data. Correct? Increase the information density. That means I will record the data in very small this one area. Correct? Small area. That means I make my disk to rotate faster. If disk is rotating for higher speed, I can store more data. Correct? With small parts. That's how I increase the density. Reduce the data access speed. Higher the speed disk rotates, I can write more data or read more data from the hard disk. So this is called that read rate access speed. Correct? I can access at a higher speed. But problem is, since this is a moving this one, the cantilever is floating above the rotating disk, very small gap, few micrometer. The disk is rotating. There should not vibration. If any vibration is there, the read rate will go and touch and scratch the surface. That is not allowed. So that means this cantilever should be vibration free. Correct? You have to make that the cantilever moves on top without touching hard disk. So you need to control the when cantilever vibration. There's a special vibration isolation algorithms which is used to see that the read rate moves smoothly without touching. So that we have to do. Right? No vibration. And spindle motor with the fluid bearings, because I know that there should not be any friction. They use special kind of fluid bearing, then air bearing they call it. Using that, the disc rotate very freely at constant RPM. So this is another example of mechatronic system. Then we'll show another example for mechatronics, a washing machine. Correct? I told you mechatronics everywhere. From your house, washing machine, micro fridge, right? and wherever automation is there. Then coming to office, you have Xerox machine, correct? Printer, laser printer, all these things are mechatronics. Because mechanical drum is rotating and it picks the paper, there are a lot of mechanism. So if I want to see about washing machine, this is the cut section view. I see many of the picture got from internet. It is not my own picture, correct? That's why I'm not able to share, because but I'm mentioning it, this I got it from House Stuff Works. It shows a very nice picture. What are the parts of this one? The main part of this one is the tub, correct? Tub is in which you put your cloth inside and also fill with water, and the tub will be rotating clockwise, anti-clockwise, 180 degree. Meanwhile, the center agitator, you can see that it is attached to a motor, correct? This is agitator motor, correct? This motor is controlled by a microcontroller, embedded controller. Okay, so this agitator will be rotating clockwise, anti-clockwise. Also, drum also will rotate. Apart from that, what are the parts are there? If you washing machine, you can see that main thing is the drum in which I am going to fill water and add detergent, and the drum will be rotated at clockwise, anti-clockwise, plus or minus 180 degree. Same way, the agitator will also move in opposite direction, 180 degree plus or minus. So what happens is, the water is filled, the drum is filled with water and detergent, and the cloth is inside. The water will be agitated. So the agitated water will go inside the fibers of the cloth and remove the dirt. That is how the washing machine works. So the main parts of the washing machine are, if you see it, drum, correct? Then agitator. Then you have what you have is a 4 important actuators. One is water pump, correct? So you know that from overhead tank there will be a connection which will be connected to the water pump backside of the washing machine. Job of the pump is, whenever you switch on the washing machine, the pump will switch on and fill the water. The washing drum will be filled with water. Right? The drum will be empty. For example, the washing drum maybe capable of having 20 liters of water. Correct? Depending on washing machine size, some machine can, small machine can have 10 liters. The capacity, correct? Water capacity, our bigger machine can even 30-40 liters. But standard washing machine will have 15 liters. It can hold. So now, you have this one. Then there are 2 valves. In this one, the pump is not directly connected to this. You will see here, this is a water pump. Correct? Pump is the motor going to drive, correct, from this one and suck the water. Now, the main motor is here. Correct? There is one more motor here, and the motor is connected through pulley mechanism, because if it is a little complex, maybe this one. And using 2 motor, one is spindle motor, other one is pump motor. What will be sucked in, right? So what happens is, now if you see washing machine, it has a control panel. In washing machine, you will see what type of cloth you are going to wash, whether cotton cloth, silk cloth, or synthetic, or jeans material, thick material. You can select type of this one. Depending upon type of cloth, the amount of water to be filled, amount of the detergent should be added, and how long the washing cycle, that means agitating this one, washing cycle to happen varies. So that means depending on water, what I am going to fill in the machine, I can select the type of the cloth. So washing cycle I can select. Then I can select type of how much water should be filled. Please remember, washing machine can take up to 20 cloths. I am talking about I have a washing machine in my home. It is an automatic machine. They say I can put 20 cloths maximum, shirt, pant, or whatever maybe. Approximately 20 count. Okay. If I put 20 cloth, the drum should be filled up to brim. Up to top, I want to fill the water. That is 15. For example, I think 15 liter or 20. I don't remember. Approximately around 15 liters. Water I can fill. If I put 20 cloth, I need to fill up, the washing drum should be filled with 15 liters of water. Okay. For example, suppose in my home I am alone, my family is not there for 1 week. What I do, every day I may have 1 or 2 cloths, correct? Even if I wait for 2 or 3 days, I may get 6 or 8 cloths, correct, shirts, all these things, mass cloth, all these things. So, and I want to wash only 10 cloths on given day, and then there's no need to fill this washing drum full capacity, 15 liter. It is waste of expensive and rare commodity nowadays worldwide. Correct? Clean water. So that means I don't want to wash, fill my drum with 15 liters. I fill 7.5 liters of drum is sufficient. We select the water level. Correct? I can say half tank only, because in my machine I have 6 levels. I think 5 levels. Correct? So I can sell level geometry, fill only 1/5. To 2/5, 3/5, 4/5, full. Correct? So this is how it goes. I can select here depending on the number of cloths. I'm getting a 4 cloths or 8 or 12 or 16, 20. I can select the amount of water to be filled. Unnecessary water is on. So I can select. Then third one is washing type. In new machines, once you select the water level, type of the cloth, automatically there is a computer which is called ECU. It knows how long washing cycle should go, whether 20 minutes, 25 minutes, 30 minutes. Apart from that, this machine doesn't have. You can see here, this is inlet water hose, this is a drying hose, and then water inlet valve. Okay, so this is connected to my overhead tank. Overhead tank has the water. This is pipeline coming from this, and here I have inlet valve. Similarly, I have a drain valve. And then this is the drain outlet. It goes to drain. Correct? In my drain, I connect a hose. Now, that's what I am going to talk here. I have water pump which is going to pump the water from the overhead tank by opening this valve, and allows the water to be sucked and filled in this one. So that is done by this pump. Then water outlet valve is there. Water outlet valve, while I filling the drum, the inlet valve will be open. Correct? This valve will be open. Outlet valve will be closed. Okay. Then drum will be filled with water, getting filled. Now after that, my machine automatically adds the quantity of detergent. There's a small bowl in my machine where I can fill with a detergent. Correct? So for 100 ml liquid detergent already filled. Correct? But depending on washing amount of water, the type of cloth I select, washing machine will add some 20 ml, 30 ml. Correct? Depending upon the washing machine manufacturer decided. He will recommend particular type of washing detergent. Correct? Most of washing detergent follow. So then from here it will add in the water. After that, based on the program, the agitator will be moving, and also the drum also will move. Washing sales starts. Washing will be done for some 20 minutes. Once that is over, what will happen is the drain will be, the inlet valve already closed, drain will open, the dirty water will be removed and goes out. Okay, so that is one thing. This is called cold washing. Correct? If in your modern machines you have a water heater also, you know that if you use hot water, dirt comes easily from the cloth, can be removed easily compared to cold water. But if you have a silk cloth, correct, you should not use hot water. Silk fiber will come out. If you use hot water, you have to use the cold water only. Correct? But if you have a jeans material, correct, your jeans shirt, all those things, or cotton shirt or something, pant, correct, or saris, the cotton material, the dirt will be embedded deeply. It won't come with cold washing. In that case, you can heat the water also. So there's a water heater inside my washing drum, and then I can select what is the temperature I want to heat. Water can be heated up to 100 degrees. Beyond the 100, it become vapor. Correct? Now when I fill the water, it is 30 degrees. Correct? There's a coil, water heater, and if I switch on, the water will be get heated. For example, I set 50 degree recommended. If you see a shirt, ready-made cloth pant, they said hot washing is somewhere in the corner they mentioned. What will be water temperature you can use? You should not have boiling water, color will fade out. correct? So I can set what is the temperature. There will be, I can select. If I select hot washing, correct, then what I will do, I select what is temperature, 50 degree, 60 degree, 40 degree, or 70, I think something around that. Beyond that, the generate no result. So I can select. So now this is what this one. What are important parts? I have electronic control to UCU, correct? Then I have a signal control amplifier. We'll see what it is in the course. We are going to read it. Okay. Then I have 4 type of actuators. One is water pump, which is going to fill the water inside. Other one is outlet valve to drain the water from this, correct, from the drum to suck and to throw it to dirty water. Clean water is going to come from pump. And there's an inlet valve, correct? There's an inlet valve. Similarly, there's an outlet valve also. Okay. Then I have electric heater. Then I have the motor. This is the main motor, correct? Main motor, which is going to rotate my drum, and also agitator. Agitator, when rotates clockwise, this will rotate in anti-clockwise 180 degree. That's how most of the washing machine, the drum will be rotating 180 degree anti-clockwise. This will rotate clockwise, correct? When this rotates reverse, this will go like this, so that the water inside will be agitated, and the velocity is created. The water will, with the detergent, it penetrates the cloth fibers, remove the dirt. Okay. Now, being automatic washing machine, I selected what type of cloth, what is water level, and also timer also can select, or I automatically select. Then temperature control. These 3 parameters I control, correct? I say so many 10 cloths, fill the tank with half level only, because I have only 10 cloth. And time is, for example, my machine automatically selects. I think I have LG machine at home. It selects automatically some 25 minutes, like cold washing, for 10 class off filled. Correct? Otherwise, it goes 35 minutes also. If I select 20 class and fill the water, then temperature I can select. Now, if I selected 50 degree, accordingly, water will be first heated. Then detergent will be added. Already cloth is inside my this one drum. Then the washing cycle starts. Washing cycle goes for 30 minutes, for example. Correct? So drum will be rotated clockwise, anti-clockwise 180 degrees, same way agitator. So after 20 minutes, most of the dirt in my cloth will be removed. Okay? Then my water becomes dirty water. So that should be removed. So what I'll do, I will open the outlet valve, and so again the water will be pumped out to drain. Once that is drained, what will happen is, again the drum will be filled with fresh water. Again this pump will be operated, fresh water will be filled only to half level, because I have select half level. Once it filled, my cloth is there, but the dirty water gone. Still some more dirt is sticking to my this one detergent. That is called a rinse cycle. Right? This is called rinse cycle. That time fresh water is added. Again the agitated drum will work, move clockwise, anti-clockwise for 10 or 15 minutes. So all the dirt and remaining detergents will be removed. Again, outlet valve will be closed. The pump will be stopped. No water comes in, and inlet valve also closed. Okay, water is filled, and now one more only fill. I have a water level sensor in my washing machine. There's a water level sensor. This is my water level sensor. It measures what is current water level. Once I selected 50% of the drum capacity. Once water level comes, automatically this pump will be closed. Okay, then the heat will be switched on. Water will be heated to 50. Rinse degree or 60, whatever I said. Cycle happens. Once this cycle 20 minutes, again outlet valve is open and water is sent out. Please tell, only during heating time the heater is on. During rinse and washing cycle, outlet drain valve is closed, inlet drain valve also closed, inlet valve also closed, the pump also closed. Okay, so that time this motor roller works. Okay, now water temperature measured by this, the motor speed, what speed, bigger drum has to rotate, correct? What speed it rotates, you measure the sensor, and many of the this one, correct? Lid, closer, door, correct? And while washing or the machine is working, this will be completely closed. You suppose, for example, in your house, somebody opens and the machine is still running, kid something, you put a hand, it can damage, break is, you are including adult hand also, it can be broken. Agitator is more torque. So generally, it should be closed. So there is a sensor which checks whether the door is closed or not. Washing machine door is closed or not. If it is open, even if you say start washing, it won't start. So first the embedded controller. Who is doing all these things? The electronic control unit. What is sense the water level, temperature level, speed, whether the washing machine door is closed or open. All these things. These are the sensors which is attached to this washing machine drum. Correct? So you see that signal is coming from here, comes to a signal amplifier. Please note that most of the sensors provide signal in the order of millivolts or microvolts. Correct? Those signals will be amplified. That is what called signal amplifier, electronic amplifier. Amplified signal will be sent to electronic control unit. Electronic control unit is going to monitor the sensors, accordingly control the actuators. Switch on the pump, correct, or spindle motor, or switch on the water heater, or open the inlet or outlet valve. These four are called actuators. These four are called as sensors. Based on sensor information, the electronic control unit, for example, automatic camera we saw. Before that, we talked about robot. Today, we saw hard disk also. Okay. And the main thing is, when you come back, washing machine, this is another best example. If you ask to write a mechatronic system example with a functional block diagram, you need not draw this diagram. I am not expecting this. Okay, but you need to draw. This is called functional block diagram. This is my washing machine mechanical system. Inside it, I have my agitator. Correct? That agitator is there. That's what is shown here. This is the agitator. I have not shown here in this picture functional block diagram. Inside drum, it is expected is there. The drum and the agitator are controlled by this motor, rotating clockwise 100 plus or minus 180 degree. Correct? Both will be rotating during washing cycle and rinse cycle. Okay. Now rinsing is over. Now what happened? Still rinsed water also removes any remaining dirt. Water also will be drained out. After that, if it is a fully automatic machine, correct, or semi-automatic machine, correct, complete the water, but just drained only. Correct. Still the cloth. Generally, if you manual washing, what you will take? You take your cloth and twist it with your hand. That's why we are doing for thousands of years. Washing, you use two hands, hit it on a stone or something, or use a wooden roller, roll it. Different method of hand washing. That's why before invention of washing machine, for last 2,000, 5,000 years, humans are doing that manual washing. Correct. That's what this machine is doing. Once the rinsing is over, correct. What you will do? You have to remove the water so that my cloth will dry quickly. So I take for example, my shirt, two ends, I twist it. So the water in the fibers will be removed. So here you cannot do twisting. Instead of that, what will happen? The spindle will remain constant. The spindle will not rotate. The drum will rotate at high speed. Correct? At high speed, maybe 8,500 RPM, drum will be rotating. Correct? That is called drying cycle. Washing cycle, rinse cycle, RINSC, rinse cycle, washing cycle, drying cycle. During drying cycle, what happens is this drum alone will rotate at maybe 800 to 1000 RPM. Correct? During washing, this one will rotate only 180 degree, clockwise. You can see the machine you would have seen. Correct? It will rotate, will not rotate continuously. This will rotate the spindle agitated will be opposite direction. So water inside will be get agitated, correct? So they will go inside this one cloth fibers, remove the dirt. During drying cycle, the spindle will not rotate. Only the entire drum will rotate continuously for 10 minutes. During that, automatically you can see that there are holes, correct? Through these holes, water in this one, due to centrifugal force, it will just come out. Correct? Centrifugal force, this one. End up after 10 minutes rotation, machine stops. It says that my washing is over, complete. You give a beep. If you go and see that, almost partially dry condition. Still wetness will be there. You have to put in the sunlight. But if it is a fully automatic machine, after that, they will pump hot air also. I have seen full automatic is available. Only thing it is little expensive. You pay 50,000-60,000 rupees, fully automatic machine. After the drying cycle, first to remove the water by rotating my drum at high speed, 800 RPM, due to which the water in this one will be removed to small hole in the drum, comes out, drained out. Then hot air will be pumped inside this for 10 minutes. So the cloth will dry. You can literally take the dry cloth, do your ironing and wear your shirt or cloth. Okay, and so this is how it works. So now, if I wanted to mention how it works, I can say flow chart. First, I have to start, then program my machine. What I say, programming my machine. The next step is this one. I say what type of cloth, correct? How much water level, whether hot wash or cold wash. All I am going to select through this, right? Cold wash, and if the hot wash, what is temperature? Temperature equal to what? I have to set. After that, I can select the start. I will say that next step, all those things are done in this step. Next step is start the machine. Once start the machine, what will happen? First, the inlet valve, this valve will be open. Inlet valve will be open, and the pump, the water pump will be switched on. Water pump on. Okay, so then once it is filled, already I selected how much water level. So the water level is rising, correct? It is increasing. So the ECU, the electronic control unit, will sense amount of water, whether reach off level using water level sensor. Measure, sense the water level. Okay, next step. After that, water level reach means add detergent. Add detergent depending upon type of the cloth you have selected. Already you select type of cloth. Depending upon the machine automatically say how much whether 10 ml, 20 ml, 30 ml. Already there's a separate this one compartment in which I already filled my detergent. Maybe 100 ml I filled. Correct? Every washing, it may take 20 ml, 30 ml, 20 like that. So it adds the detergent. Then what it will do? Start washing cycle. Correct? So once washing cycle over, say for example 20 minutes, the washing cycle stops agitating. Correct? Stops. Then water will be drained. Correct? But before draining, what you have to do? Water draining before open outlet valve. Correct? Outlet valve will be open. This outlet valve will be open. Outlet valve. Then drain the water. Once there is water, again close the outlet valve. Close outlet valve. Again fill water. By again pumping water. Okay, pumping water, fill water for rinse cycle. Again do rinse cycle. Again similar to agitation, the drum will rotate clockwise, anti-clockwise. Agitate also this one. Any remaining dirt and detergent cloth will be in the rinse cycle removed. Again open the outlet valve. Open outlet valve and drain the water. Then go for dry cycle. Correct? So this motor the spindle motor, main motor, will be made to rotate at constant RPM. For example, 800,000 RPM for 10 minutes something. So all the water is removed. Once that is removed, the machine stops. Correct? So this is the flow chart. If you are asked to write about washing machine, what you are expected to write is, correct, this functional block diagram. The control panel used for program. This is the control panel. Setting the washing cycle, water level, timer. If it is heater, is there heater level, right? Heater and what temperature, all this in front panel. So that will be read by ECU. You are programming my ECU. This is how you have to do the washing cycle, depending on type of cloth you design. And you instruct this one, the front panel. Inside this, there's an embedded program. Who has done that embedded program? Read the control panel, the water levels, all these things. Based on that, there's a control algorithm that is done by the washing machine manufacturer. This is a small computer, just like any other machine. Then, as I told you, shown the flow chart, the washing cycle starts. Filling, open the this one valve, switch on the pump, fill the water level, heat the water if needed, heat the water level, correct? Then do the washing cycle, rotating anti-clockwise, then open the outlet valve, drain the water, again fill water, again fill up to after water level, start the rinse cycle, do it, again drain the water, then close the outlet valve, then start the drying cycle, rotate the drum at constant high speed so that water is removed from a cloth due to centrifugal force. Then what you will do? The washing machine completes. So during washing operation, water level is sensed by this, water temperature is sensed by this, motor speed is measured to see that the motor is rotating constant speed, water speed, whether door is worsened. So you have to draw the functional block diagram and draw the flow chart what I showed and explain about what is job of individual. Correct? So these are the individual components, these are the actuators, these are the sensors. Correct? You list the type of, so draw the functional block diagram, write the sensors, write the actuators, and then draw the flow chart, explain. So you may get a question for 2 or 3 marks. Explain the washing machine, automatic washing machine working with proper functional block diagram. In washing machine, we have a display, correct? Temperature, water level, and any error code. If in there, it will show you a display, small LED LCD display will be there. Cycle over means some information will come. If machine stops, it's an error message. All those things shown for the display. You any doubt in this?
No, sir. Everything is fine.
Okay.
Sir, show that the text what you should display for improving the hard disk, sir. I wanted to just make a small note of that.
Yeah.
Thank you, sir. I'll be very quick. I'm sorry.
Okay. So there are many other examples, satellite control. We have many examples we can talk. I will directly go to engine. Correct? I think time up. You have the other faculty waiting. Okay. I will tomorrow we'll see another example. If you see the syllabus, today I have sent the syllabus. You can see that we are going to see already the last example, last section. Our last chapter is example for mechatronics system. That's what we are discussing. It's a different example. Robot control, correct? Washing machine, IC engine control, what mechatronic, what sensors are that we are discussing in the beginning. So you will have an idea. Correct? The last section of syllabus is we are talking now. Examples of mechatronic system. We saw automatic camera, we saw washing machine, we saw hard disk, and before that we saw robot also. 4 example. The 5th example will be fuel injection system, which is relevant to the automobile people. We will see how the fuel injection system works, correct, as an example for a mechatronic system. And that will, after that, we will talk more detail. Sensors. Already we talked of introduction, what is mechatronic definition, all those things already talked. And now we are seeing the examples, which is the last chapter. Generally, I thought that giving more idea would be better. Case studies, we call it case studies, we are seeing And then we will see one by one mechanical system modeling. Then we'll see about sensors in mechatronic system, what are the actuators, how they are working, the control system, all those things we will see. And signal condition, amplifier, op-amp, transistor amplifier, filter, electronic filter circuit, ADC, DAC, and also embedded control, what is microcontroller, embedded control. Correct? Each one will deal with 2 to 3 hours. Correct? So sensors will deal for 2 to 3 hours. We'll see some at least. So most of popular, there are more than 20, 30. All these sensors we cannot see. Basic type of sensor will understand. Correct? Like force sensor, torque sensor, temperature sensor, some 5 to 6 sensor widely used sensors. Similarly, actuators, motors, DC motor, stepper motor, how it works, what is internal vibration, servo motor, then hydraulic motors, correct? Hydraulic valves, all those things we'll see 3 to 4 hours. Each one will be covered 3 to 4 hours. Correct? We are around 6 section or 7, and approximately we'll be able to meet. Okay, 42 hours is the total time. Any questions today? No more question means you can give attendance. Correct? As a chat message. We'll see you tomorrow. Tomorrow we'll see about electronic control unit, ECU for SI engine control, and what are sensors, all those things, how it works, flow chart, I will explain. Then we'll go to next, this one, sensors for mechatronics, like that. Okay.
Okay, sir.
Thank you, sir.
Thank you, kind of you. See you.
Thank you, sir.
Tomorrow.
Thank you, sir.
Okay. Okay. Bye.
Thank you, sir.